Hello students, in this video I am going to explain chapter number 13 Hydrocarbons of class 11th chemistry. Hydrocarbon is important source of energy, and here are some examples in which hydrocarbons are present completely. It is very much clear from the examples of hydrocarbons how hydrocarbon act as important source of energy. Next comes the use. Hydrocarbons are used in making polymers like polythene, polypropylene, polystyrene, etc. And higher hydrocarbons are used as solvent in paint. Next comes the classification. Hydrocarbons can be classified into three broader categories: saturated hydrocarbons, unsaturated hydrocarbons, and aromatic hydrocarbons. Saturated hydrocarbons are also called as alkanes, and it has carbon-hydrogen single bond or either carbon-carbon single bond. Alkanes or saturated hydrocarbons are also called as paraffins. The combination of two Latin words, param means little and affins means affinity. And the saturated hydrocarbons are inert under normal conditions because they do not show reactivity with acids, bases or other reagents. That is why saturated hydrocarbons are also called as paraffins. Next comes the unsaturated hydrocarbon. It is further of two types. At least one carbon-carbon should contain double bond in case of alkenes, and in alkynes at least one of the carbon-carbon bonds should be triply bonded. And aromatic hydrocarbons are special type of hydrocarbons. Now alkenes, it contains, as I told, carbon-hydrogen single bond or carbon-carbon single bonds. Its general formula is CnH2n plus 2, where n stands for number of carbon atoms and 2n plus 2 stands for number of hydrogen atoms present in the molecules. All the carbon-hydrogen bond angles are 109.5 degree, as in case of methane. I will show you. Here you can see the structure of simplest alkane called methane, in which tetrahedral structure is there with bond angle 109.5 degree. Hydrocarbons are made up of word root and suffix. If the hydrocarbon contains one carbon, then word root meth is used. And for 2, eth, for 3, prop, for 4, but, pent, hex, hept, oc, non, and tec. The suffix in case of alkenes is ane, and in case of alkenes, ene, and in case of alkynes, ine is used. Suppose you have 5 carbon atoms, and after adding the hydrogens we will complete its tetravalency, and this type of formula is called structural formula. So what should be the name of this alkane? Since the carbon-carbon bond is single, so it is alkane. And total carbon are, if you count, it is 5. So word root pent should come, and carbon-carbon single bonds are there, so suffix should be ane. So its name is pentane. Now we'll study the type of carbon atoms in alkanes. Let us understand this with the help of an example. So let us take one example. This is one compound, and its name should be 2,2,4-trimethyl pentane. Now our focus in this compound is to determine what type of carbon atoms are present in it. If the carbon which is directly attached with only one carbon atom, then that type of carbon atom is called as primary carbon. In this sense, the first and fifth carbon atom should be the primary one. Even this carbon atom is primary because it is directly attached with only fourth carbon. And this is also primary, and this carbon is also primary. Now let's have a look at the second carbon atom. It is directly attached with 1, 2, 3, 4 carbon atoms. So this is 4 degree carbon atom or quaternary carbon atom. Third carbon atom is directly attached with fourth and second carbon atom, means 2 carbon atoms. So this carbon atom is secondary carbon. Similarly, now the fourth carbon atom is attached with How many carbon atoms? The fourth carbon atom attached directly with 3 carbon atoms, so this is tertiary carbon. So in this way we can determine the type of carbon atoms in alkene or any other hydrocarbon. Next we will study about the preparation of alkanes. Number 1, by dihydrogen gas. When to the unsaturated hydrocarbon like ethene, the simplest alkene, when we add hydrogen and platinum or palladium or nickel, then saturated hydrocarbon ethane is formed. Next is from alkyl halides. When alkyl halides is reduced with zinc and dilute hydrochloric acid, then alkanes are formed along with HCl. Next method is Wurtz reaction. When alkyl halides is treated with sodium metal in the presence of dry ether, then higher alkanes are formed. Next method of preparation is from carboxylic acids. This is decarboxylation reaction. When sodium salt of carboxylic acid, the sodium ethanoate, and common name is sodium acetate, is treated or heated in the presence of soda lime, combination of sodium hydroxide and calcium oxide is called soda lime, then carboxyl group of the sodium acetate is removed. This group is removed as it is clear in the form of sodium carbonate. That is why this method of preparation is called decarboxylation reaction. Next method of preparation is Kolbe's electrolytic method, in which aqueous solution of sodium or potassium salt of carboxylic acid on electrolysis give rise to alkanes. Let us see how this reaction goes on. This is sodium acetate, and in the presence of water, electrolysis is carried out and ethane is formed, and these are the side products. Sodium acetate can be converted into ethane by Kolbe's electrolysis method. Now let us discuss the mechanism of Kolbe's electrolysis method. At anode, oxidation of acetate ion into carbon dioxide takes place, and it results into formation of acetate ion free radicals and methyl free radicals. Here the homolytic cleavage is taking place at this position. Like this, bond breaks, so methyl free radicals are formed. In the second step, these methyl free radicals get combined to form ethane gas. At cathode, water gets reduced into hydroxide ion and hydrogen free radical. Two such hydrogen free radicals combine to form hydrogen gas. Now we will study the physical properties of alkanes. All the alkanes are non-polar molecules, and it is because of the covalent nature of the carbon-carbon and carbon-hydrogen bond, and besides there is very little difference in electronegativity between carbon and hydrogen atoms. Now about its physical state, alkanes having carbon 1 to 4 are gaseous in nature, and alkanes having carbon 5 to 17 are liquid in nature, exist as liquids. And alkanes which contain 18 or more than 18 carbon atoms, then it exists as solid state at 298 Kelvin, and they are colorless and odorless. Now let us discuss about chemical properties of alkanes. All the alkanes undergoes substitution reactions. So let's have a look on the steps involved in halogenation reaction. Methane, when heated in the presence of sunlight, it forms methyl chloride and hydrogen chloride. This is the substitution reaction. And this methyl chloride again combines with chlorine, and one hydrogen of methyl chloride gets substituted with chlorine atoms, and it forms dichloromethane. And dichloromethane, CH2Cl2, on reaction with chlorine, it gives rise to chloroform, CHCl3, and its IUPAC name is trichloromethane in the presence of HCl. And this chloroform, when further allowed to remain in sunlight, then it gets decomposed to form carbon tetrachloride and HCl. Let us discuss now about the mechanism of halogenation reaction. It has 3 steps: chain initiation step, propagation step, and termination step. Let us start with the initiation step. Chlorine molecule, in the presence of sunlight, the bond between Cl and Cl gets break down, and it undergoes homolytic cleavage, which result into formation of chlorine free radical. In the second step, which is the propagation step, in this propagation step, chlorine free radical attacks on methyl, and it forms methyl free radical and HCl. Now on methyl free radical, chlorine gas attacks in the presence of sunlight, and it forms methyl chloride and chlorine free radical. And on this methyl chloride, this chlorine free radical again attacks, and it forms chloro substituted CH2Cl dot free radical and HCl. And CH2Cl free radical is further attacked by chlorine molecule, and it forms dichloromethane, CH2Cl2 plus chlorine free radical. Third step is the termination step. Now in the reaction mixture, we have chlorine free radical, we have methyl free radical. So there are possibilities that chlorine free radical may combine to form chlorine, methyl free radical can combine to form ethane, and one methyl and one chlorine free radical may combine to form chloromethane. So hence free radical all get consumed up and reaction terminates. Now move to next property of alkane. When alkanes are heated in the presence of air or oxygen, then it oxidizes completely into carbon dioxide and water, and large amount of heat energy is released, kilojoule per mole. So now the third chemical property is controlled oxidation. When alkanes are heated with regulated supply of air at high pressure in the presence of suitable catalyst, then it gives variety of oxidation products. For example, in first case, I am taking copper catalyst at 523 Kelvin temperature and 100 atmospheric pressure. Then in this case, methanol is formed. If we take same reactants, that is methane and oxygen, but in the presence of molybdenum oxide, then formaldehyde or methanol plus water is formed. And if we carry the reaction of alkane in the presence of oxygen, in the presence of catalyst CH3COO twice Mn, manganese acetate, then we get acetic acid and 2 molecules of water. So different catalyst is resulting into different products. Next is isomerization in alkanes. When alkanes are heated in the presence of anhydrous aluminum chloride and HCl gas, let us take N-hexane, this is the alkane, then it gives rise to branched chain alkanes. So 2-methyl pentane and 3-methyl pentane are formed. So both the compounds have same molecular formula, but their structures are different. Next is aromatization. Alkanes having carbon atom 6 or more, like here I am taking N-hexane. When these are heated in the presence of high temperature and 10 to 20 atmospheric pressure, and catalysts like chromium oxide or vanadium pentoxide or molybdenum oxide, then aromatic hydrocarbon benzene is formed. Next is reaction with steam. When methane is heated with steam in the presence of nickel, then CO and H2, this gas is formed, which is also called as syngas, SYN, synthesis gas. Next is pyrolysis. When higher hydrocarbons like hexane are heated at higher temperature, then it gets breakdown, decomposed into lower alkanes. For example, in case of hexane, it breaks to form hexene plus hydrogen, butene plus ethane, and ethene plus propene plus methane. So this is pyrolysis reaction. This was all about physical and chemical properties of alkanes. Thank you.